Have you ever wondered how a neural network works? Well, let's unravel this mystery together. Neural networks are the backbone of artificial intelligence, the force powering today's tech revolution. They're inspired by our very own brain, an intricate web of neurons exchanging signals at lightning speed. Similarly, a neural network is made of interconnected nodes or artificial neurons that process and pass on information, emulating the workings of the human mind. Imagine a toddler learning to walk. With every stumble, they understand better how to balance and move. Similarly, neural networks learn from experience, improving their performance as they process more and more data. They're not just part of sci-fi movies anymore, they're right here, enabling your virtual assistants, recommending your next favorite song, even diagnosing diseases. Neural networks, in essence, are the brainchild of our brain's working model. But what makes up a neural network, you may ask? Picture a neural network as a multi-layered sandwich. The outer layers, known as the input and output layers, are like the bread, while the hidden layers nestled in between are the filling. The input layer is the entry point for data, like an image, a sound, or a text. This data is then passed on to the hidden layers. These layers are where the magic happens. They're packed with nodes or neurons, which process and transform the incoming data, like a complex game of telephone. Each neuron is like a mini decision-making machine. It receives information, processes it, and then passes it on. This process continues layer after layer until the transformed data reaches the output layer. The output layer then serves up the final result, whether it's recognizing a face, understanding a spoken word, or predicting the weather. So a neural network is a complex web of layers and neurons all working together to process information. Now, you may wonder, how does a neural network learn? Well, let's simplify it. The learning process of a neural network is somewhat akin to how humans learn. It all starts with training. Think about it as a school for neural networks. During training, the network is fed with a multitude of data points, each associated with a correct answer. This is where the weights and biases come into play. These are parameters that the network adjusts to map inputs to the correct outputs. But here's the kicker. The network initially makes a lot of mistakes, but it's these mistakes that are the bedrock of learning. The network uses a process called backpropagation, which is essentially learning from errors. The network tweaks its weights and biases based on how far off its predictions were, and over time it gets better. In a way, neural networks learn much like we do, from their mistakes. Neural networks are powerful, but they're not without their limitations. One of the major strengths of neural networks is their ability to handle complex, nonlinear problems. They can analyze large sets of data, find patterns and trends, and make predictions with remarkable accuracy. But it's not all sunshine and roses. Neural networks have a voracious appetite for data. They need large amounts of data to train effectively, and this can sometimes be a limitation, especially when dealing with rare events or small data sets. Additionally, neural networks are often referred to as black boxes. This is because it can be challenging to understand how they arrive at their conclusions, making them difficult to interpret and trust for critical decision-making. Yet despite these challenges, the power of neural networks is undeniable. Their ability to learn and adapt sets them apart in the field of artificial intelligence. Despite their limitations, the power and potential of neural networks in shaping our future cannot be overstated.